Alright, for example 2, we have another two-piece function. Let's read this together. F of x, wow, huge parentheses, reminds me of a spider. Top piece, f of x is 2x minus 1 whenever x is less than negative 2. Bottom piece, f of x is equal to x squared whenever x is greater than or equal to negative 2. Remember, folks, just graph it one piece at a time and you'll never go wrong. So let's go ahead and graph the first piece. So remember, you're going to take this value that's part of your interval and plug it into your piece. So I'm going to figure out 2 of negative 2 minus 1. Or f of negative 2, so that gives me negative 4 minus 1, which is negative 5. And because there's no bar here, and I plugged in negative 2 and got negative 5, there's going to be a hole at negative 2, negative 5. Alright, now I want to plug in points to the left of negative 2, right? Yes, because its x is less than negative 2. So I'm going to plug in negative 3 into my top piece and get negative 7. And so at negative 3, negative 7, it's solid. Why? Because negative 3 is part of this interval. Negative 2 is not, right? Negative 3 is less than negative 2, so it'll be a solid point. Now, I know that 2x minus 1 is a line, so I'm just going to stop there. I only need 2 points for a line, one of which is a hole. So there's my hole at negative 2, negative 5. There's my solid point at negative 3, negative 7. And I'm going to start at negative 2, negative 5 and construct a ray that goes through negative 3, negative 7, and then it's going to continue forever. Again, I know it's a line because it's 2x minus 1. So there it is, folks. There's my top piece. It's literally that simple. Why do I not pick points to the right of negative 2? Because that's not part of my interval. Only x is less than negative 2. All right. Step 2, graph the second piece. So we're talking about this. I hate when that happens. We're talking about this bottom piece right here. X squared whenever x is greater than or equal to negative 2. So I'm going to plug in my negative 2 into x squared, and I get 4. It's going to be solid because there's a bar here. Negative 2 is part of this interval. So I'm going to have a solid point at negative 2, comma 4. Alright, next up, what should I plug in now? Well, I need to plug in something bigger than negative 2, right? So why not negative 1? Negative 1 is bigger than negative 2. And it's part of my interval, so therefore negative 1 squared is 1. I'm going to get a solid point at negative 1, comma 1. Now this is quadratic, so I can't just plug in 1 point. I have to keep going. Let's plug in 0 now. It's also bigger than negative 2. I get 0 back. Again, 0 is bigger than negative 2, so it's going to get a solid point. Let's plug in 1 also. 1 squared is 1, so 1, comma 1 is also going to be solid because 1 is bigger than negative 2. And why not plug in 2? So let's keep going. The more the merrier. Plug in 2. 2 squared is 4. 2 is bigger than negative 2, so 2, 4 is going to be solid. And so all of these points right here I'm going to plot, and they're all going to be solid. And I know it's quadratic, so I know it's going to be a parabola, so I can indeed connect them with a U-shape, even though it's pretty obvious that it's U-shaped based on these points. And that's it. I graphed my piece down here. I graphed my piece up here. And yes, they do share a common negative 2, but they don't exist both at negative 2. Only the top piece does. And so therefore it will be a function. It will pass the vertical line test. But again, folks, like I said before, this is easy. You're just graphing one piece at a time. Sometimes they overlap, like in example 1, and sometimes they don't overlap, like in this example. If you have any other questions about this, let me know.